Let's do some calculus review, Calc 1 review. This is part 5 of this particular video. So, part 5. Next question I have. A 15-foot ladder, so 15-foot ladder, is leaning against a wall, vertical wall. So, here it is, house or something. Here's our ladder, okay? So here's a 15-foot ladder. And it is moving, it is starting to fall. It's moving away from the ladder, from the wall at 2 feet per second. So it's going this way at 2 feet per second. And when it is 12 feet from the ground, so at some point I'm going to have 12 feet right there. Question is, how fast is it going down the wall? All right, so that's where the question is at that instant. So we've got 3 pieces. We've got the ladder, we've got the horizontal, we've got the vertical. So I'm going to name these with X's and Y's. I'm going to call these X's and these Y's. Now, literal X's and Y's have to do with lengths. So let's talk about this. I'm going to make an assumption that that's a right angle. So I've got a Pythagorean theorem problem. Got x squared plus y squared is equal to 15 squared. Now at the instant we're talking about, not always, but at the instant we're talking about is what happens when y equals 12. Okay, that's the question piece. So we've got x squared plus 12 squared, which is 144, is equal to 15 squared, which is 225. So if I subtract 144 here, subtract 144 here, we get x squared. Okay, here we get 1, 8, and 0. So x squared is 81. X equals 9. Now, I look like I'm cheating on algebra, but minus 9 doesn't really make sense. We're measuring distances. You could put minus 9 if you want. It would stick it over this side, but that doesn't really play too much of a role here. Okay, other things. Now, we've got a rate, related rates. So this is the x side, and it's changing at 2 feet per second. This is getting bigger. So dx dt is equal to 2 feet per second. This one is the question. Dy dt equals, I don't know. That's what I'm trying to find out. Now I've also got to have an equation that relates these. Well, what do you know? I do, right here. Now I can't put 12 in here all the time because it's only 12 for 1 split second. So I'm going to leave the equation. So an equation that we have is x squared plus y squared. Now the ladder's always 15 squared because it's not shrinking or anything. They didn't say that. So derivative with respect to time. 2x times dx dt. X is not the variable of choice, time is. Plus 2y times dy dt is equal to the derivative of 225, that's 0. Now we have numbers to put in. What's x? Well, at our instant that we're going to do, we've got 9. So we've got 2 times 9 is 18. What is dx dt? We've got dx dt. It's 2 feet per second. Now you could have reduced this, by the way, factor of 2. Plus 2y, so 2 times 12, so that's 24, times dy dt is equal to 0. So if I pop this over here, I end up with 24 dy dt is equal to minus 36, and then I've got feet. This is feet, and this is feet per second, so I've actually got feet squared per second. This one's got feet on it. feet and feet squared per second. So let's divide by 24 feet. 24 feet. This is here. Okay, so we get dy dt is equal to minus 36 over 24. That's minus 3 halves. So minus 3 halves. Feet squared over feet is feet to the first per second. So there's what we get. And that's another related rates problem. You've got to keep the actual numbers out of anything that changes until the very end. And so we did that. We tried to label every part and then find some derivatives. Okay, another word problem. Let's suppose we have some kind of a situation where we have a rectangle. We're going to make some sections in this rectangle. Now, so you don't get the idea that it's 1/3 each place, I'm going to do that. I'm going to label this X and this Y, and I need to have these straight lines add up to 4,000. That's fence. So we've got 4,000 feet of fence. Now our goal is to maximize the area. Okay? Well, here's the deal. We've got Y here, Y here, Y here, and Y here. So we've got 4 Ys. We've got X here and X here. So plus 2X is equal to our 4,000 feet of fence. Okay, I'm going to simplify a little bit. I'm going to divide through by 2. I don't need to have fractions, but I'm going to divide by 2. So that gives me 2y plus x equals 2,000. Now actually, to make that even easier to deal with, I'm going to move this guy over here and say that x is 2,000 minus 2y. Okay, so now I've got x and y in relationship to each other. Now these do not describe the area. So what's the area? Well, the area is length times width, x times y. So that is, well, what's x? X is here. It's 2,000 minus 2y multiplied by y, which is 2,000y minus 2y squared. Okay, so we've got a with respect to y, or y is a is a function of y. So let's take dA dy and get the derivative. So derivative of 2,000y is 2,000. Derivative of minus 2y squared is minus 4y. We need to find a critical value to maximize that. So set it equal to 0. You get 2,000 equals 4y. So divide by 4, you get 500 equals y. So if that's the case, then you're going to have 500, 500, 500, 500. Okay, so y is 500. You're going to use 2,000 feet of the fence. You've got 2,000 left, so x is going to be 1,000 each. Okay, 2,000 minus 1,000 is 1,000 for x. Now, is that maximum? I don't know. So let's use a second derivative test. This is a great time to do that. So let's take d squared a dy squared. That's a second derivative. Derivative of this is minus 4. Plug in y equals 500. You get minus 4. Remember, that's concave down. Gee, there's a max up there, isn't there, if it's concave down. So yes, it is a max by the second derivative test. Kind of a nice time to use that. Okay, well, let's take a look at a few kind of general derivative problems. Let's say that we've got a position function, s of t is equal to 4t minus 7t squared plus t cubed. T cubed. Find the velocity. Velocity is s prime. So derivative of that one is 4 minus 14t. and this is t cubed, so plus 3t squared. Let's see, some more derivatives. F of x equals the log base 3 of x. This is a log, but not log base e. So f prime, well, log functions tend to be 1 over, so 1 over, but log base 3, we've got to divide by the natural log of 3. That's the thing that you do to take care of this being the wrong base. F of x is 4 to the 3x plus 7. What's its derivative? Well, f prime is, this is an exponential, so it's itself, times the derivative of the exponent, since that's complex, a little bit complicated, so times 3. These don't go together, by the way. And then wrong base, it's not base e, so we've got to multiply by ln of 4. So that's kind of nice. Now, let's find the derivative if we've got sine of 5x minus 4. So sine of 5x minus 4. So the derivative, f prime, is cosine of 5x minus 4. Chain rule applies, so times 5. Let's find f double prime of x. So we've got 5. That sticks around with us. Derivative of cosine is minus sine. The angle never changes here. Minus 5, or 5x minus 4, times the derivative of the angle, which is 5. So we end up with minus 25 sine of 5x minus 4. Here's another one. What if f of x equals the cosine inverse of x? Now you might remember that one. I'm going to make this look a little easier. I'm going to say y equals the cosine inverse of x, or in other words, the cosine of y equals x. And I'm going to use implicit differentiation. So, cosine of y equals x. Derivative of cosine minus sine. Okay. Multiplied by the derivative of the angle, dy dx, is equal to the derivative of x, which is 1. So this is equal to what? Okay, so dy dx equals minus 1 over the sine of y. Now, it doesn't look like that if you look it up in books. So let me point this out. If the cosine of y equals x, draw yourself a right triangle. Here is the angle y, okay? The cosine is x, so adjacent over hypotenuse. Well, Pythagorean theorem, this thing squared plus this thing squared equals 1. So this is the square root of 1 minus x squared. So that is what we've got. Now, the derivative is minus 1 over the sine of y. So dy dx is equal to minus 1 over, what's the sine of y? Well, it's the opposite over the hypotenuse. So 1 minus x squared. Now that's what you'll find in books. So it's usually in terms of x. Let's take another example. And this one is find dy dx if x equals cosine 2y. So derivative with respect to x, 1. Derivative of cosine minus sine of 2y. Derivative of the angle is 2 times dy dx, implicit, okay? So divide everything off except for the dy dx. So we get 1 over minus sine 2y and a 2. I should put that there. Is equal to dy dx. Okay.